Hello. Today we are doing lesson 12.1 that we started in class, the inference for regression. And so we'll be dealing with both intervals and tests. We started example 1 in class. We entered our data into our calculators and did the calculation linear regression. You could do AX plus B or as I did over here, A plus BX. And I've showing you the dot plot and the regression line here. So as you should with all work that you do, any variables you have, you should be defining them. So y hat is the predicted IQ, and x is the number of peaks in crying. And that, of course, was for 20-second time periods. The regression equation then becomes y cap equals 1.5x plus 91.3. R squared is 0.207 from our screenshot there, and R is 0.45. So examine the residuals. So you can do stat plot L1 resid, and I got this plot on the right. If it doesn't work, mine didn't work for some reason when I entered in resid, so what you can do is to store your residuals into L3 and use L1 and L3. So what we found here is there is no apparent pattern in the residuals, and so the linear model seems appropriate. All right, the next thing we're being asked to do is to predict the IQ of a baby with a cry count of 30. To do that, we simply plug in 30 into our equation. So there's 30 in the equation, and when we work that out, we get 136.3. So the predicted IQ is 136.3 for a cry count of 30. Okay, the next thing we're being asked to do is create a 99% confidence interval for the slope of the true regression line. That is usually the slope that we're being asked to work with. And when creating our confidence interval, the most important value to obtain is standard error of B. This is difficult to obtain by hand, so typically you will be given computer output for these data, for these values. So for instance, we have a Minitab output for this regression. So in this example, we will use this, and then in the next subsequent example, we'll be having to come up with SEB ourselves. So first of all, please note that these values are different than ours. And so we will use these values from here on. Okay, so on here, you can see predictor, they've got the constant and the cry count. So the coefficient for the cry count, that is our slope, B. The SE coefficient, so the standard error coefficient, 0.470, that is SEB, 4870. Okay, we are looking at a 99% confidence interval. And if you recall from the lesson earlier, notes up above, n minus 2 is our degrees of freedom. So the degrees of freedom equals, in this case, 36, because we had 38 samples. So n was 38. Degrees of freedom becomes 36. So in this case, we're going to use the table. Use the table for our critical value. And when we look that up, we will see that 36 is not in the table, so we will use a degree of freedom of 30. We need to be more conservative, and that gives our critical value T star of 2.750. So the formula for confidence interval is the estimate plus or minus the critical value times the standard error of our value, so of B in this case. So confidence interval is, our estimate was the cry count coefficient, so 1.4929, plus or minus our t-value, which is 2.750 from the table, and SCB from our data is 0.4870. When we calculate this out, we get a confidence interval of 0.15365, I believe, to 2.83215. Okay, so that's confidence interval, and of course we would need to make a conclusion and check our, do all our checks and whatnot. So now we're going to test the hypothesis of no linear relationship. Null value of the null hypothesis, is that there is no relationship between the cry count and the IQ. So in other words, beta equals 0. Now remember that our hypotheses are always about parameters, not about statistics. So we use our statistic of B to find, as an estimate of our, to help us decide whether our beta, which is the parameter, is 0 or not. Our alternative hypothesis is there is an association between cry count and IQ. In other words, beta is not equal to 0. So there was no significance level provided. So we will choose 0.05. Our degrees of freedom, as we calculated above, is 36. So it's n minus 2. The test statistic calculated by hand is, from our formula, T equals B minus the null hypothesis beta over SEB. So in this case, it is 1.4929 minus 0. And if you're writing out your equations, make sure to put in the minus 0. Don't just drop it out. Divided by 0.4870. And so T then becomes 3.066. All right, moving on. Our p-value, if we were to draw a little sketch, this would be a two-sided, and so we're looking at the tail ends. And for two-sided, this is 0.95. And so TCDF, we're going from to the lowest one here, negative E99, negative 3.066, and 36. And so then we get 0.00204988 when you calculate that out. So that only gives us the left-hand tail end. So what we need to do then is the p-value equals 2 times 0.00204988, which is then 0.0041. Okay, that value is less than, less than 0.05. And so we are going to reject H naught. The conclusion then, since alpha is greater than the p-value, and of course make sure that you do actually show your math for that, as well as you can show your statement, or just put them in right here. 0.05 is greater than 0.0041. We reject the null hypothesis, and conclude there is a linear relationship between cry count and IQ. Okay, so your job now is to check your work with the calculator. So you're going to go stats, tests, linreg, t-tests. So let's have a look at what that will be. All right, so here on our calculator, I'll just jump back out to show you. We're going stats, tests, whoops. And if you go down, you will come to, oh, there we go. Second last one on my calculator, linear reg t-test, and we enter there. So X list is L1, Y list is L2. We're going to choose beta is not equal to 0, and then we can put the go variables, Y variables function, and we can choose Y1 because this should be the exact same function that it plops in there as to what we already did before. So calculate, and here's our data. So we'll put that on our screen. Okay, so from our data we can see that we get the same t-value, the same p, degrees of freedom. So yes, that does check out. So now you know you can do it on the calculator or by hand. Does the p-value indicate that the linear regression line fits well? I want you to think about this. All right, so hopefully you came up with no. So if you didn't, think about what does tell us whether the linear regression line fits well. And the answer to that is the R, which is correlation, and R squared tell us about fit.